Hello everyone, welcome back to the Maverick channel. Now on this channel we talk about real world use cases of digital currencies. How can these technologies be applied into the real world? So of recent we've seen the crypto market take off. We've seen Bitcoin take off. We've seen increased positive sentiment around Bitcoin. A lot of people are making statements such as the ban of Bitcoin and Bitcoin related activity within China was good for the whole crypto space. It dropped the hash rate for the Americans. It drove a lot of the miners and a lot of activity from China into the United States. So we're seeing growth in Texas and other states that are becoming more and more accepting of what this technology is going to do. We're seeing more and more influential people have skin in the game in this ecosystem, and as more of these, whether politicians, wealthy people, institutions, retail investors that have their own sort of mindset to create technologies that can drive these things forward, they're developing an interest in this technology, which is going to eventually lead to an exponential increase in terms of the usability, in terms of real world applications, and all other types of applications that we haven't even wrapped our heads around. Now, I want to read this article. It was written on the 2nd of September, which means it's a bit dated, but it's referring to a very good demonstration that was carried on by Mobix or Data, which is a company building on top of the Fetch.AI ecosystem. Now, I want to cover this particular document because it covers a couple of things. It talks about why they use the agents, at least briefly talking about that, the different partners they use like HTWSR, Fetch.AI Ocean Protocol, and how they leverage Ocean Protocol and their technology, which is the DeepParking technology. Other concepts like self-sovereign identity and decentralized identities as well. Now, the reason why I want to cover this is because in the Fetch.AI ecosystem, there's something called a simple open economic framework. So basically, this is where the autonomous economic agents reside. This is where they get to make their decisions. This is where they get to either act individually in an abstract manner or dynamic manner, depending on what's going on, or even leverage a better sort of activity or presence by leveraging a communication based around other agents as well. So leverage what other agents have in order to make the best decision for your owner or whatever use case you're required to do. And by your, I'm referring to an agent in this case. So to better understand these things, we have to understand that an agent residing in an open economic framework, in order to act properly, it has to be within this environment, which is referred to as an economic framework, but this environment needs to be able to detect the different characteristics that an agent has. In other words, how do I detect these agents? For the agents, how do we negotiate and communicate with each other? And that's where the Fetch.AI ecosystem employs things like the FIPO protocol, which is a standard that's being developed as regards peer-to-peer communication. Then they use things like the lib peer-to-peer communication framework or standard to allow these communications within agents. Basically, agents communicate at the most basic level of understanding. They communicate by sending themselves things we call envelopes, or packaged envelopes, and this is how they initiate this communication process. And that's one of the reasons why I'm very excited about agents, because they sort of mirror, if you look back at the internet when it had just started, basically the internet was about sending emails from one person to another, and once that was perfected, then we started seeing evolution of the internet into social media, into actually using, right now seeing video games, video or vlogging. The video aspect of the internet is really catching on, and you're seeing animated GIFs and all these things. So for an agent to perform properly within an open economic framework or a simple open economic framework, first of all, let's define what a simple economic framework is. So before we get into this document of the Mobix and how they're leveraging these open economic frameworks, the autonomous economic agents, we have to understand what is a simple economic framework. So this is a search and discovery mechanism for AEAs. This is how they search for each other. This is how they find each other. So, and as it develops, it will develop into a full-scale decentralized multi-dimensional digital world. So within there, agents can register themselves. So agents register with a simple economic framework and are able to conduct search around them and to find other agents in this space. An agent has different characteristics. So agents describe themselves in terms of identity, personality pieces, and service keys. The identity of the agent can be described as the ledger addresses, the ledger types, the given names, for example. For the personality pieces, is basically how an agent looks like, which kind of protocols it supports, the transactions it supports, and we have something something called a heading, so it represents the heading of the agent. And then service keys, so what do these agents do? What do they sell? What do they buy? Are they buy agents? Are they seller agents? And what do they want? So these are fundamental basic structures of how an agent is. And within, for example, the personality pieces, you find things like the genus, the classification, and architecture. So just like in biological classifications, you find a hierarchy of classifications of species. So for example, the last classifications will be genus and species. An example, for example, a lion, if you don't know what the name of a lion is, you don't know what lion is, it's also referred to as Panthera leo, where Panthera is the genus and Leo is the species. So you see this kind of philosophical nature of agents and how they mirror the structure of our physical world and the way we understand different characteristics of organisms, whether living or non-living. So this intuitive nature of these agents allow them to develop these characteristics that are very important for them to reside within a dynamic environment and to be able to make decisions, well-informed decisions on behalf of their owners in these types of environments. So these things like also the architecture and also the classification itself. You can have, for example, mobility.railway.station. You can have mobility.railway.train, mobility.road.taxi. You can have infrastructure.road.sign. So there's different ways within that agent, and with all these different characteristics. So agents are also characterized as service keys, and agents can have different or multiple types of service keys. We can have examples of service keys like buying genus, buying architecture, buying classifications, and basically, so we've talked about these different structures, which means that agents need this simple economic framework as their world, a place where they can negotiate with each other, transact with each other. We also have different characteristics like basically if you have a blockchain, you can have data like machine learning data calculated off chain, and then permanent data. So basically that's transient data, and you have things like permanent data like transactions or proof of transactions. These things are actually stored on the blockchain. So you can have agents actually acting as a second layer type of technology, sitting on top of various distributed ledger technologies, but these are things that we'll cover sometime in the future. So let us read this simple document here to understand what was going on, what was being said here. So the self-sovereign identity acts as an underlying identity and communication protocol between agents on Mobix DeepParking use case at the IAA mobility event. This was the event in Munich, Germany. So it allows for the integration of verifiable credentials and communication via private and encrypted communication channels between agents. So actually, let's look at this video here, and at the end of the video you'll see what they note, what they say at the end of the video. So you can have two open channels between two players. These players can communicate, transact. Of course, this happens with the agents, and after this communication is done, these transactions are done, these agents close off these channels, and there's hardly any proof that these two parties actually transacted with each other.
At the IAA in 2021, Mobix demonstrated a deep parking process using Fetch.AI autonomous economic agents and SSI. A network of Fetch AEAs works on behalf of car, parking garage, and micromobility services identities. The Mobix smartphone app connects with the car by scanning the QR code associated with the car's identifier. The car's AEA, from now on car, now acts in the user's interest and communicates with the user through the Mobix app. The car initiates a search for an optimal parking space for the user in her destination area. It does this via the Fetch.AI open economic framework. The user is presented with the best parking choice the car could negotiate for her and reserves this parking spot using SSI technology. While she gets on her way, her car is negotiating the best e-scooter deals in her target area using Mobix privacy-preserving special offers powered by Ocean Protocol. For a Mobix reservation fee, the user can reserve her preferred scooter so it will be available when she arrives. When arriving at the parking location, the user initiates the car to open the barrier. Car and parking barrier exchange a verifiable credential via SSI, and the gate opens. Now the car is safely tucked away in its parking space, and the user can ride her reserved scooter to get around town. When she returns, she ends her scooter ride and gets back into the car to leave. When approaching the gate, she informs the car to initiate the barrier opening. The parking process is now ended, and the car requests a forget-me, which is a GDPR-compliant data wipe on the involved parking AEAs. Wait a minute, what just happened? There's a little robot head in the corner. You tap on it and you can read along what the involved autonomous economic agents have been communicating while the user was enjoying her best choices on parking and riding. We'd like to thank our partners who helped build this proof of concept. Mobix continues working on implementing this awesome technology for its audience.
So pretty impressive stuff. So from the 7th of September to 12th, 2021, the IAA Mobility, the largest mobility fair in the world, takes place in Munich, Germany. A large variety of car manufacturers, suppliers, and micromobility providers show their latest future products and offer live demonstrations in coordination with Bosch, HTW SAR, Fetch.AI, Ocean Protocol, and Data Rela. Mobix will demonstrate its new micromobility use case using DeepParking technology. So just like you saw in that video, that was a very good demonstration of how you can actually use these DeepParking technologies. So the use case offers a combination of a dynamic search and booking of private parking lots in the city center of Munich that were offered by individuals or private companies. So additionally, users have the possibility to seamlessly rent a micromobility service like an e-scooter to get the target destination that might not be available by car. So providers of parking lots will get rewarded with a parking fee which is paid out in the Mobix token that resides on the Fetch.AI blockchain. Remember, there's going to be an airdrop, I think on the 20th of October, so watch out for that. You have to be staking on the mainnet. On the Fetch.AI mainnet, you get an airdrop of these Mobix tokens. So self-sovereign identity, this is one of the key factors to look into, especially we that are looking into these blockchain and distributed ledger technologies. These are some of the features that are going to be predominant in the future. So privacy plays a central role in the Mobix ecosystem. Therefore, we choose to implement an SSI or self-sovereign identity ecosystem based on the Aries framework Go. Now, if you look into this Hyperledger Aries framework Go, so which means this is actually created by the Hyperledger team. Very exciting stuff. Those that haven't looked into the Hyperledger is one of the most complex ecosystems out there, one of the most excited ecosystems out there. So this Hyperledger Aries framework Go enables trusted communication and data exchange based on interoperable distributed ledger technologies and peer-to-peer interactions. So you can see this fits into the lib peer-to-peer that Fetch.AI connected to. It fits into the interoperable nature that these agents are trying to seek out. So it's very interesting stuff, and these partnerships and technologies are really pairing into each other very, very properly, like a glove fits into the hand. So the user will have a Mobix wallet that contains a mobile SSI agent to connect to the selected car and to find and reserve a parking lot. So the cars also run on their own SSI agents deployed on Raspberry Pis inside the car. So Mobix has prepared 3 parking lots in the city center that are managed by a website that is called the Parking Hub, which broadcasts the availability of parking lots to the Fetch.AI simple open economic framework. So the Parking Hub is the only agent that issues a verifiable credential to attest the successful reservation of a parking lot and issues it directly to the car. So to make the credentials verifiable, the Parking Hub hosts a public decentralized identity on the ID Union ledger. So the ID Union ledger, basically, if you look at this website here, it's a German website, but you can translate it to English. They have a feature here. You can just click here and you can read more into this ID Union. Basically, they want to also create a standard for this kind of interoperability nature of decentralized identities. So we can see this consortium. We know that Fetch.AI formed a consortium called Katina X. We also know there's others like Gaia X. So the purpose of this consortium is to allow different companies, automotive companies and companies that have a common interest to come together and share knowledge that's supposed to help propel the future of things like autonomous travel, autonomous manufacture, autonomous money, communication, improvement of supply chains, improvement of DeFi and centralized finance. So these are different features that these conglomerates, through these consortiums of organizations, they're trying to figure out how to optimize and share data that would help propel these kinds of ideologies. So when the car approaches the parking space, a gate control unit requests a credential presentation of the reservation and verifies the credential signature with a public key that is registered on ID Union. So after the car arrives in the parking lot and the driver exits the car, the connected agents revoke their connections and essentially forget that they ever interacted with each other. A very similar approach is implemented for the micromobility solution, where the user connects the e-scooter and provides credentials issued by the micromobility hub. Now, people, they say that pictures say 1,000 words. So here we can see that you start off with your phone, basically, which is the user device or mobility age agent, basically onto this phone. And then we can see here, the first thing before anything happens, we can see that there's an anchorage of the decentralized identities. So basically what this is that solidify these decentralized identities, which are going to be the basis of these transactions, of the preceding transactions that are going to happen. Number 2, it selects the car that it's going to interact with. Number 3, it selects the parking hub. So if you think of Cosmos has these hubs and these zones, and then these hubs can communicate with each other by transferring these zones, these communications or transactions through the zones, so one hub can talk to the other. So here the kind of mirroring a similar type of technology. We can see here step 3 selects the parking hub, and then we have step 4, if I can find it, issues reservation credentials, and then step 5 presents credential proof. Then here we see step 6, this HTWSAR, which is essentially acting as the mediator to serve as the verifier of these decentralized identities. And then number 6 verifies parking hubs DIDs, and then it rotates back into the ID union ledger. So we can see a parking hub cloud agent with public IDs. So we have to remember that autonomous economic agents can reside in a Raspberry Pi, they can reside in a cloud using Docker images, and they can also exist in a command line interface or a graphical user interface. So these are very abstract and arbitrary types of structures that can exist in different types of forms. They can offer different types of value. We also know that the added advantage that AEAs bring onto things like smart contracts are inherently reactive. So the agents bring a proactive nature to smart contracts, making them smarter, making them more autonomous and automatic in the way they operate. So the decentralized identities, let me make this dark. So the decentralized identities that are natively provided by the Aries framework Go are derived from the DID peer method. This DID method generates each decentralized identity for each counterparty individually to create private and encrypted communication channels between the actors. So this avoids the possibility of correlation of connections in the verifier's side. Furthermore, all connections are automatically revoked. So in summary here, they're saying that the SSI plays a central role within the Mobix DeepParking use case and the entire Mobix ecosystem. So this implementation allows for the trustless exchange of verifiable credentials while fully respecting the user's privacy. It uses well-known standards like DIDs and verifiable credentials and anchors the public DIDs on the ID union ledger. So furthermore, this design is scalable as any actor can run as an Aries framework Go agent independent of their underlying infrastructure and be added to the network. And here, of course, they're just saying if you're interested in seeing us in person, show up at the IAA and contact us. We're excited to explain it to you on the site. So of course this ended, but the reason why I wanted to go through this particular article, of course, apart from the side that it was perfectly written, but also at the end of the video, remember the video we watched at the beginning, at the end you can see how these agents actually talk to each other. So there's a demonstration. So in other words, if you looked at the back end, you wouldn't just see code being run. You can actually see in human readable English or whatever language, I'm sure they'll be able to translate that in the future. You'll be able to read how these agents are communicating with each other. In other words, they talk to each other. Hey, there's a car here, there's a parking lot here, let's make a negotiation. I'm going to accept 3 Mobix tokens. That's a bit of a steep price, so they negotiate. Okay, let's meet in the middle. I'll accept 1.5 or 2 Mobix tokens. And we can see this intuitive nature of how these agents talk to each other, and by leveraging the simple open economic framework, by leveraging the dynamic nature of autonomous economic agents, you're able to see, and also the privacy nature of these technologies and the different sort of value and use cases that can be brought forth by leveraging both off and on-chain type of interactions through oracles and creating accurate price feeds and tapping into graphical user interfaces. These technologies are about to bring a type of value that we haven't even seen yet, but they're ultimately going to create real-world use cases of distributed ledger technologies and humans and machines. They're going to create that trilemma of interactions between these DLTs, humans and machines, and the way we actually interact with this world in a real world use case type of way. Alright guys, thank you for watching. I hope you really learned something from this video today. Some of these things are convoluted and it's not that easy to put them together, but I try to put them together in the best way that I can, at least personally. Alright guys, take care, have a good one, bye bye.